I do want to go through the second day of Change the Base. There are 3 problems I want to go through, and then you guys will be able to work on your assignment after we correct the front side and go through questions on that, of course. But when would we want to change to a base other than 10? So if you have a log base 7 over log base, or log base 7 of 16 over log base 7 of 32. Okay, if you recall back on Friday when we talked about changing the base, if you were given, say, like log base 3 of 8, and we wanted to solve that using base 10, we could rewrite that. Tell your neighbor what goes on top there. Okay, does the base go in the basement or above? Basement. So log 3 and log 8. So log 3 divided by log 8. Now, if you recall, when we talked about this, I said, you know, if whatever we have as our base, if we called that, say, m, and we call that a, this could actually be log a and log m, and you could make this be whatever you want it to be. That base could be whatever we want it to be. I could call it base c there if we want. Okay, we could have called this a base 5, a base 5, or a base 3 and a base 3, or base 2 and 2. It's up to us. Okay, the reason we use base 10 so much is because that's what we work in primarily, is base 10. Okay, so if we are looking at something where the change of base formula has been applied, or you're looking at a log over a log, when would I want to go to something that's not base 10? Well, if you recognize, say, 16 and 32 function in a specific base, a common base, what base are those both? So they're both base 2. Okay? 16 is 2 to the 2 times what? Or 2 times itself, how many times makes 16? 4. And 32 is 2 to the 5th. So it would make sense, rather than having it in base 7, to make it base 2. And the way we do that is we just change the 7 to 2. Can you do that? Yep, you can do that. And there's math behind it that, quite honestly, I'm not going to go into right now on it. But you could do that. Okay? And if once we're done with this, everyone can check it if they have an 84. Okay? Yeah.
So are you not allowed to change it to any number?
You can change your base to any number. Yep. Yeah.
If it was like 2 different logs, so then we wouldn't be able to do that equation, right?
If it,
log 8 over log 6.
you mean if the bases were different?
Yeah.
You can only do this if the bases begin the same.
Yeah.
Correct. Jaden?
Can the base be more than 10?
Yeah. Yeah. Yeah.
So then you would just like simplify that?
Yeah, and so now I just simplify it. 2 to the 4th is 16, so log base 2 of 16 is 4. And 2 to the 5th is 32, so log base 2 of 32 is 5. So that answer is 0.8, or 4/5. For those of you that have the calculator, a calculator where you could actually type in log base 7 of 16 and log base 7 of 32 and divide them, when you divide the two, you should get 0.8, or 4/5. Okay? That's why we might want to change something other than base 10 currently. Okay? So sometimes we go, well, it's tough if I don't know when I'm going to apply something like that. Well, you might apply this in this setting where you want to go to a base 2 because you recognize both of these are in base 2. All right. Questions? I want you to write this as the common log. Okay? Write this as the common log. So in order to write it as the common log, you need to know what common log means. Remind your neighbor what common log means.
Log base 10.
Common log is base
10.
Base 10, not 8. Base 10. All right, so if I'm writing this as the common log, that is log what? Log what? Log 19 over log 12. You just change them, right? You just change the 4 to 10 because they're the same already. Now you have base 10. Okay? Questions there? Write it as a single log now.
Is it just that?
Nope. Okay, for those of you struggling, let's go back to this. If I have log 8 over log 3, that came from this single log. Okay, so if I'm writing it as a single log, what goes to the base? Good. What's in the basement, right? 12. And then what's here? 19. Log base 12 of 19. That is my single log. Okay. How many had it before I gave the hint? How many got it after I gave the hint? Okay. How many had to wait till I put the answer? Okay, that's good. All right. Let's try that one. Write it as a single log. Okay, the question here right now, does this base 6 matter? It doesn't matter because it could be base whatever we want it to be. Right? So really the only two numbers that matter in this, are the 7 and 5. Okay, so our new base is 5. What's in the basement? Log base 5 of 7. Questions on it? Dylan?
The only thing I'm like kind of confused about is just like how you can change like the logs to anything you want. Like you can change the bases to anything you want.
Well, the best way I can explain it right now, and it's not using log forms, but to where you would you would get where we're at. If you think back to pattern. Well, first, before I do that, are there any questions on this? How many got that? Okay. So let's think back for a minute to like when I have 5 to the second and 5 to the. All right. So let's say I have 5 to the third and 5 to the second and 5 to the first and 5 to the 0. Okay. And each time, this becomes 125. This is 25. This is 5. This is 1. Right? Okay, and each time you're dividing by 5. Well, when you're dealing with logs, you eventually get back to that 1 as well. Right? Every time, when we're dealing with another base, we still get back to that same 1. Right? It's just we're dividing by a different amount every time. And that's kind of what's happening with logs. Okay, now it's not exactly, all right, but the reason you can change the base is because bases have similar things they're doing. You're dividing by a common amount here, just like when you have this base, you're dividing by 5. Here, when we have 27, we have 9, we have 3, we have 1. Here, you're dividing by a common amount. Okay, and that's happening with logs. Remember, logs are just inverses of your exponents. Okay, so when we say, well, why is anything to the 0 1? Well, it's because you're dividing by a common amount each time. Now, it's not the same thing depending upon the base. All right, when you're dealing with this, where we can divide by the same, it doesn't matter what this number is. It's because the bases function in that similar way. I don't know if that makes sense. Okay, but if we called this base 10, since you're in the same base, okay, the proportion is going to be the same.
Okay.
Log base 10 of 7, log base 10 of 7 divided by log base 10 of 5 is proportional to log base 6 of 7 divided by log base 6 of 5.
That makes sense.
Okay?
Yeah.
All right. Okay, let's go ahead and take a look at our assignment from Friday. Let's correct what we, or from Thursday. Let's correct what we did, and then we'll go through questions. Add it to what we do today. Okay, so are there questions on that side? Any questions? Yeah.
33 and 34.
33 and 34. Here we go. Number 33. The first thing to always do is the step should be to write it as a single log. So if you recall, first thing, write as a single log. Okay? In the case of 33, we already have it as a single log. Okay? So after we write it as a single log, write it in exponential form. All right, so we want to write this in exponential form. We can't, we're not going to break anything apart here in terms of 3x minus 2, but this is base 10. And if you recall when I was talking about this last week, just for some of you who like to see movement to cause something to happen, when that moves over here, that base 10 now becomes base 10 in exponential form. This 10 to the third equals 3x minus 2. Once again, mathematically, that's not exactly what's happening, but that's the result of it. Okay? So you have 3x minus 2 equals 10 to the third, or 1,000. 3x equals 9. Oops, not 9. Equals 1,002. Unbelievable. Okay? And then x is 334. Okay, so that's 33. Good there? Okay, 34. So again, first step is to write it as a single log. So first thing we have to make sure it's the same base, which it is, and the same number in front, which it is not. So we'll move that 2 in there. So that becomes log of x squared minus log 5 equals negative 2. Single log, since they're subtracting, we apply the quotient property. So that's x squared over 5, the log of that. Now that you guys know the change of base formula and the quotient formula, do not change or do not mix up the two. Quotient formula, you have log and then you have a fraction. Change of base, you have log on both parts of your fraction. It'd be a common mistake for some people. Okay? And then once we get it as a single log, the next step is to go exponential. So this is base 10, so we move it over. So that's, as we swing that over there, that becomes 10 to the negative second equals x squared over 5. 10 to the negative second is 1/100th. Okay, so you have x squared over 5 equals 1 over 100. Then cross multiply. 100x squared equals 5. Divide by 100, 5 100ths. Then take the root. X is equal to root 5 over 10. And we don't have to worry about the negative root, right? It would usually be plus minus, so we can't have a negative because you can't take the log of a negative. So if we put that in for x there, it wouldn't work out. So we were rounding to the nearest hundredth, so 0.2 what? 2? Okay. Good questions. Other questions? Cool.
How do you do number 27?
27. 27 is not a log, so in this case, if it's not a log, you want to write it as a log. So start out by doing that. So this would be n minus 2 to move a variable out of an exponent spot. Always write it as a log. We have base 4, so that's going to move over. That becomes log base 4 of 3. Okay. That gets the variable out. And now we use the change of base formula over here. Log 3 over log 4. Oops, log 4. In minus 2. So in, we add 2. Take log 3 over log 4, whatever that is, and add 2 to it. That gives us in. Cool? Yeah. We would want to simplify that, right? Like 0.39. I think it is. Okay. Go ahead.
I'm not sure if you did this, but I did it like where I did log of 4, and then it has n to the 2 in that power, and then equals log of 3, and then you solve that. When you bring it over, it just gives you n minus 2.
Sure.
And you solve it like an equation.
Yeah, you could just impose the log on both sides.
Okay.
That's what you did. That would have been fine as well. You could have taken the log of this and then moved the n minus 2 over. Yeah.
Just to see it.
Yep. That would have been fine. Other questions? Yeah?
Could you show how to do 18?
18?
Yeah.
Kind of the same thing we just did on that other one. Okay, where this is, you could write it in exponential form. So it's base 5. Sorry. Base 5. So as we move that piece over, that becomes n plus 1. By moving it over, it gets that out. Yeah.
So when you say impose the log, you mean like it would be the n plus 1 log 5 equals log 3?
Yeah, let me do that after I do it this way.
Okay.
Yep. Okay, and that's negative 0.32. And it's okay to have a negative here. Okay. That good? Okay, yeah, you guys, when I'm saying impose the log, the other way to solve this problem is you could actually impose it. You could make that say log of 5n plus 1 equals log 3. So you're just putting the word log in front of each of them. And then use the product property to bring that out. So the other way of doing this would be like this here. And then divide, since we're multiplying here, divide by log 5. So we get n plus 1 equals log 3 over log 5. And n equals log 3 over log 5 minus 1. Which once again, you get our negative 0.32. So when I say impose the log, it means you're putting it in there.
Yeah, that's what I did for
Other questions? As we spend 2 days on things because we want to make sure we get them right. Now, technically, we spent 3 days on this now. This will be our 3rd day. So we're going to look at the mixed side right now. So take a look at that. Your assignment on the mixed side. No, we don't. Oh, you guys want to do them all. That's crazy.
Wow, it's like
I'm
you got
impressed,
all
though.
to
Thank
us.
you. All right. We are going to be doing these. Oh, yes. Now take a look at tomorrow. Tomorrow's a review. Okay? In class tomorrow, you will have time to go through and ask questions. You'll have about 20 minutes of class to work on this and ask questions prior to us grading it. Okay? Plus the 25, 30 minutes you have right now. Okay? So work hard. I mean, you may finish right now and not have any questions tomorrow. We'll grade it after about 20 minutes of class. Okay? And then tomorrow we have a review. I'm also going to hand out your portfolio page. It will not be due until next Monday. Okay? And you cannot finish this portfolio page right now anyway. You don't know everything there is to know. But this portfolio page is a pretty quick one. So I just wanted you to have it out just in case you have time. You have 1, 2 graphs, 3, 4 graphs. I'm putting 2 on there. Answer that question, and then give an example of all your properties of logs. Pretty easy portfolio page, but you won't be able to quite finish it yet because we haven't done the natural log yet. Do when?
Monday.
Do Monday. Monday the, I don't know.
Well, that's really reassuring.
Monday 3-2 we'll go with. All right. You have your chapter test next week. Woohoo!